Greetings and welcome. In this series, we are going to make a point-of-sale system using C# as our main language. We are also going to be using a database, and we are going to use Microsoft SQL for that. Visual Studio is our IDE. So the first thing that we have to do is we have to create a new project, and we have to select the language. Like I said before, we are using C#. And under platform, you have to select the platform that you intend to run this software on. You can choose Mac OS if you are developing from a Mac computer, and the rest of the people can choose Windows if they're running Windows. So in my case, I'm running Windows and I'm going to stick with Windows. Then on project type, we'll select desktop. In this project, I would recommend that you choose Windows Forms app and ensure that in brackets it's written .NET Framework. After typing the project name and selecting other options, we select Create, and there we have a new project which has just been created. So this is what your IDE should look like after creating a project. But just in case your IDE looks different, it's safe to click on the window menu, then select Reset Window Layout, then confirm that choice. So if your IDE looks something like this, we need a toolbox. So you can select the View menu, then you select on Toolbox, because we are going to be picking items from the toolbox into our form. Before we proceed, you may want to know a few tricks about how to navigate your way around Visual Studio. All the panels that you see, they can be moved around. Like for example, this toolbox, you can drag it from one corner to the other corner depending on your preference. As you drag any of these panels, you must notice a couple of boxes that show up on the screen, like the T that we have at the center and the 4 boxes that we have on the 4 different sides of the screen. Each of these boxes, they pertain to a place where you can fix your panel. Like for example, let's say we want to fix this panel on the left corner. We can just drag our mouse to the box on the left, and as you can see, when it shows that blue transparent box, it shows you where the panel will be fixed after you release the button. So if we release our mouse button, the toolbox will be fixed there. And we can also fix it at the bottom, but for a toolbox, this is not exactly a good place. So normally for toolboxes and for the Solution Explorer, normally the left or the right are good enough. So all the boxes, they can be moved around in a similar way. And also each of these panels can be collapsed or it can be expanded depending on what you're trying to do. Like in this instance, we want to design our form. So as for me personally, I prefer it on the left side, so I can drag items from the toolbox into the form. But also notice there is a button which looks like a drawing pin. It is after the close button. So we have the close button, then the auto hide button. So if you don't activate this button, when you click away from the toolbox will automatically close, or it will automatically hide. So you have to click the toolbox again to show it. But if you want the toolbox to be fixed, maybe you are still designing your form and you are going to be using the toolbox a lot, you can activate this button so that the toolbox becomes fixed. And if you notice, your form will be pushed to the right a bit. That is, if your toolbox is on the left, it will be pushed to the right, just to give you a clear view of your form which you are designing and the toolbox from where you are deriving your components. So you can collapse it after you are done. So since we are still developing the user interface part, we may want to collapse the Solution Explorer, but we want to expand the toolbox. When we are designing our user interface, it is very important to assign proper names to all our controls, especially those that will be referenced from the source code. Like, for example, we have this form. We can visit the properties page for the form, and we can look for the name property, which is under design. But if you find it difficult to locate some of these attributes, you can choose to select items in alphabetic order instead of by category. So after you sort in alphabetic order, everything will be from A to Z, and the name will be among the topmost items. So let's say this is our login form. We can choose to name it login, then put FRM as a way of shortening. The FRM is a way of shortening form. So this is a convention that I just introduced, where I put the name of an entity, and what follows is the type of the entity. Like in this case, it's a login form. Then the name of the entity comes first, and the type of entity, which in this case is a form, it comes last. That's one way in which we can reference our items. The reason why this is important is, let's say somebody is reading your source code, because, for example, if we double click the form and we go to the source code view, you will notice that some of the functions will have the name that we just assigned to our form. So that name will occur whenever we want to reference the form. So it is important to make sure the form has a proper name to avoid confusion when somebody is reading the source code. It also explains which control is being referred to. Like in this case, somebody knows login, FRM is a shortened version of form. So it becomes obvious to somebody that this is a form and it is a login form. So just by reading the source code, somebody can know what is happening on the user interface. Let's say we want to create a button, or maybe let's start with a text box. So we can create a text box, and this is a text box that will eventually this is a text box that will eventually hold our username. Here I'm just putting the label as well. So we have the label for the username and the text box. So because the text box is meant for the username, we can also put it as the username txt. So that being said, if we are consistent with this convention, every text box should have a suffix txt, and every form should have the suffix frm. Well, some people choose to have the type of control at the beginning, then the name at the end. It's also acceptable, but it's important that one remains consistent in how they name their controls. So this is the username. For the label, it is acceptable to just leave it as label 1 and so on without trying to change the name. The reason being, we hardly reference labels from our source code, but for all the labels that will be referenced from source code, I would recommend that you give the proper name for the label. Like in this case, this would be a username. Because it's a label, I'll just say LBL. Okay. Most of the time, it's not necessary for labels if they are not going to be referenced in source code. But for all labels that will be referenced, they need proper names so that when somebody is going through the source code, it's easy for them to understand things without having to visit the user interface. We now need to create a label and another text box for the password. We can drag them from the toolbox, but an easier way is to just select what we have already created and we hold the control key. The control key is written CTRL on the keyboard, and it is the bottom left key on the keyboard. While holding the control key, we can drag these two elements to a desired position. As you can see, we've managed to duplicate them. The next thing that we are going to do is we are going to change the text on the label that we just duplicated, and it's supposed to be the password label. And we are also going to change the name for the password text box. But I'll also shift my properties panel from the right to the left so that you have a clear view of what I'll be doing in the properties panel. Okay. I'll select the label which is meant for the password. It's still written username because we copied it from the username label. So we have to change the name to password. We shouldn't worry much about the name because we won't be referencing it in our source code. Then we also have to change the name of the text box to password txt. So all our text boxes have the txt suffix. Then because it's a password text box, it shouldn't have any visible characters. So just to test, here is what we want to avoid. A password box shouldn't show the characters that were typed. So for us to hide the characters, we need to select an attribute which is written use system password char. So it forces the text box to show the password character. So the default character for passwords on the operating system is the one which will show instead of the actual text. So this is a way of hiding anything that the user would have entered as a password. Okay. we may want to increase the size of our text boxes. This is not mandatory, but it can help. Let's see if we enlarge the size a bit. So let's have a preview of what it will look like with text. Okay, this is large enough. So just leave it like this. It's okay. Definitely we need to change the title for our form. This is the login, but because it's a point of sale system, you can just call it POS login. Okay. Then the next thing that we need is buttons. One button to log in, so we can put it somewhere here. And we may also need a button to create an account if there is no account, or maybe if another user wants to create an account for themselves. So this one is create account, then this one is login. Then again, for buttons, we need to give them proper names. For buttons, this is a login button. So we say login and BTN. Others would prefer to say BTN login, but whatever convention a person chooses, they should be consistent in it. So if you choose to have BTN as a prefix, you have to stick to that. But if you want BTN at the end of the name, it's still okay. Personally, I prefer to put the type of the control at the end. So for create account, we can do the same. Create account BTN. So there we have our login box. So let's just run the program and see what it looks like. Okay, it started on a different monitor, but let's drag it. Okay, we have this problem where our focus starts on the password, then it goes to the username, then the create, then login. We'll try and fix this error a bit later, but for now, I think everything looks okay. Okay, everything is working fine. And if we close the form, the application also terminates. Now, in order for us to log in, we need to have a working database. So that's what we're going to design next. At this point, we want to design a database so that we can use it with our application. So the database is going to be responsible for things like logging in and keeping records and so on. So the first thing that we have to do is we have to show a panel which is not visible by default, SQL Server Object Explorer. So once we activate that panel, under databases, maybe let me do this. So if we expand the SQL Server, you must see there is an option which is written MSSQL local DB. So that's the one that we're going to go with. Sometimes you can find another one which is written SQL Express. So you can use that as well to develop your applications. But we are going to go with MSSQL local DB. So that's the local database that is installed. Normally, an SQL server is installed together with your Visual Studio package. But just in case you can't find any SQL server on your installation, you can manually select it in your Visual Studio installer, or you can separately download and install SQL Express or Microsoft SQL database. You can choose a package that is easy for you to install, then we can work with that. Okay, so after we select our database engine, which is the MS SQL local DB, we are going to right click the databases folder, and it will give us a list of options, but we are going to choose to add a new database, and we can give it a name. Then we also have to select the location. In my case, I want the database to reside within the same folder where I have my project. So I'll select source, then point of sale. Then maybe let me just create a folder for databases. So this is where I would want my database to reside. Okay, as you can see, we have managed to create a database, and we should be able to navigate through the tables of this database. But since we just created it, it has to be blank or empty. If we expand our database, which is point of sale, and under tables, we should be able to add a new table. And in this case, we want to add a table which is called users. And of course, it can have an ID, but we also need a username. It shouldn't be blank, and it should be unique. Then we also have a password. It's text as well. Then we need the name of the user. Maybe the address of the user. Then we also need to remember the privileges of this user. So I think we'll put privileges as an integer. Okay, I think for now, okay, for privileges, it can't be empty. So we have to so we just chose to execute that script. Then let's see if we have any errors. And yes, it looks like we have an error message. So let's see what might have been the problem. Okay, so this seems to be the problem. Oh, okay. So what we did, we added an attribute for the username so that the username is unique for each entry, but we also put the type as text, which is not supported for unique entries. So we need to convert this into a varchar. I think a varchar is more suitable for unique values. The reason is the database might need to index the username in a special way so that it becomes easy to search through other entries to see if another record exists. And all this has to be done very fast. So the database engine should not lag or it should not delay in creating a record, but it should also search through all the records. So the text type is not suitable for such fast indexing. That's why we were forced to put a varchar. So let's see what happens with a varchar. Okay, seems like this time it worked. So there we have our users table, and everything seems to have worked out well. So what we want to do now, we want to add a couple of records for the user. So this is for us to fast track our project and also to quickly test if the login facility works. So later we can reset the database table and allow users to create new accounts by themselves. But for now, just create the administrator account, the password. Let me just put password as well. Administrator's name is administrator. For privileges, let's just put okay. So I think we now have an administrator. So let's try to use this database and let's see if it's working. let's program a few actions that will be executed if our login button is clicked. So we go on the login button and we double click it. Then this is our source code view. So one of the first things that we need in order for us to be able to use our database, we need what is called a connection string. So in order for us to derive a connection string, we can right click our database, then we right click. It should be able to provide us with a connection string. So let me just copy this and store it here as connection string. So once we have our connection string, we can create a connection object, which is generally used to connect to SQL systems. Okay, so there we have our connection string. Then if it's successfully created, then we have to open it. So this establishes access to our database. Then once our connection is open, as you can see, the artificial intelligence of our IDE is suggesting that we introduce a new command. So let's do that. That should be interesting. Okay, and I think one thing that we need here is the connection that we just created. So this will allow us to create a command which is associated with the connection that we just created. So now that we have an active connection and a command, we should be able to extract data from the database. So we use the SQL data reader to extract data from the command. This should work for us. Okay, normally what I do is I just put a conditional statement. For now, we just want to see if everything works well. So let's show a message box. The first attribute in our database is an ID, which is a 32-bit value. So this one is string. I think this and the next column in our database is a username. So we must have, or maybe let me, let's try to make it okay. So what I did here I put this dollar currency symbol at the beginning of the string, just before the opening quotation mark. So what this does, it allows us to embed variables within the string, but the variables have to be surrounded by braces, as you can see. So we should be able to mix text with variables without the hassle of concatenating all the elements. So this should be easier to work with. This is what we want to experiment with for now. There's a lot that we need to do to this code in order to improve it, but let's see if it works. The other thing, I want to inspect all the actions step by step to see if everything is working as we expect. So I'll put a breakpoint by clicking on the margin. It's a bit light when compared to the rest of the background. So if I click there, if it shows a red circle, it means that place is marked as a breakpoint. So whenever this point within our program is executing, the IDE will pass control back to us so that we can inspect everything as it happens. So let's run and let's see what happens. Okay, again, everything was launched on a different monitor, so we just dragged it over. So if we click the login button, it should break to this point. Then I'm using F10 to proceed line by line. So we're trying to connect. Okay, it seems there are issues with our connection string, so the keyword trust server is not supported. What we can do is we can just remove this line, or maybe let's just remove all these lines. Okay, but we have to run our program again. Okay, this time we managed to create the connection. Then we just try to open it and it seems as though we are winning. Then we created a command, then we executed the command. So all these statements seem to be succeeding. Then this should mean that we also managed to read from the database. So we want to show a message box with the values that we, oh, sorry. And unfortunately, it launched again on a different monitor, but these are the values that we got. Remember, we had a username administrator and our password was password. Then it's at index 1. So for the sake of clarity, maybe let me also put the address and the privileges. Okay, let me close the program for now. And let me verify which column is the address. So we have the password, it's index 2, then index 3 is the name, index 4 is the address. So let's leave it like that. I think we should be able to. Okay, let me drag this over so we can see what's happening. We log in, then we proceed step by step. Then message box. Unfortunately, it's coming on the other. Okay, but at least our username is administrator, password is password, full name is administrator, then the address is 55 Falcon Close. This shows that our database is working. Okay. So I think we've managed to create a connection to our database and everything is working well so far. At this point, it is important for me to highlight the fact that it is not a good programming habit to mix things like the user interface and the specifics of a database engine. This is what we did in this particular instance. So all the logic that handles data retrieval and storage, whether it communicates with the database engine or maybe it uses file, that part should be transparent from all the other parts of the program. So in this case, our login form should have no business with the specifics of the database. It should just query information and it should just request information from a data storage, and it should get information without the knowledge of the mechanics of the data container. So we should at this point migrate all our database related stuff to a separate file. This will make it easy for us to maintain our program, and it will make it easy for others to go through our source code and to understand what the role of each file. So when things are mixed within files where we have database stuff within the login or within any other form for that matter, it complicates the process of finding bugs or even of maintaining the program. It also creates so many problems that are difficult to locate. Like, for example, later if we change something somewhere, it might break our login button. For example, let's say we changed the location of our database, so we changed the engine of our database. Our login functionality would break just because it is involved so much with the specifics of the database. So we are trying to abstract the login part from the database part, but we should still allow them to communicate, but in a way that doesn't affect or that doesn't break the functionality of the login should the data storage part change in the future. So for now, we are going to create another class for the database. Okay, we can call this db. Yes, we can call it db, then we can call it db so what we are going to do, we are now designing a class that focuses on database related stuff. So let's say we open a connection. We hold on to that connection for as long as possible before we close it. So any other request that comes, we reuse the connection that was opened. That way we don't have to keep on opening and closing connections. So this connection failed. Okay, so basically this establishes a connection, and if it succeeds, then it means okay. But it's not every time that we want to create a connection. Sometimes, okay, let's say we already established a connection. We don't want to keep on creating connections. So we have to check the connection variable if it's empty. If it's empty, that's only when we create another connection. But in this case, so this must return SQL connection. Maybe let me just do this too. Okay, so our code first checks if we have a connection. If we already have an existing connection, maybe okay, let me. So if we don't have an existing connection, then we create a connection. But whatever the case, we return the connection variable. So if we didn't have a connection and creating a connection failed, we should still have an empty value by the end of this function. But if we had an existing connection, we don't bother trying to create another connection. We just return what we already have. Then we don't need this. So this class that we are designing is what we call a static class. In other words, it's a class that doesn't need to be instantiated many times. So it is initialized once and its values, they persist throughout the program. So we only need one copy of this class. So when we are accessing the database class, we don't need the new keyword. So the next, mm, then query. So for the query statement, we need a string, then so the AI is helping us a bit there. Now we have 1, 2. We might need another function. So instead of calling this connect, we can call it, let's just leave it like that, it's okay. Then this one is called close. We try to close the current connection. Then we also try to get rid of other resources that might have been occupied by this connection. Then we should remember to indicate that the connection is now empty, just in case we want to perform another database related function. We should be able to reconnect to the database engine. For now, okay, so let's go back to our login form. And from here, we should be able to access our database. We called it DB. Let's see if everything went on well. Okay, it should. Okay, but unfortunately, the system is not recognizing it. One thing that we can do to ensure that some parts of our program are visible globally, we need to put them within the same namespace. So when we created that class, it just exists, but it's not tied to any particular namespace. So let's just ensure that it is within the same namespace as the rest of the project. So let's just put namespace, and so our namespace is point of sale. So anything that pertains to the point of sale that we have created ourselves, it should fall within the point of sale namespace. Let's try again. Let's see if we should be able to access our database from here. And again, it seems as if we can't access our database. So let's see what might be the issue. Okay, the database and the form are in the same. So maybe let me just drag this over. The database and the form are in the same folder, so that shouldn't be the problem, because we're supposed to be able to access our database from the form. Let's check, because we created the database class Let's check how it is being. Oh, okay. So as you can see in our Solution Explorer, we added the database class, but it is not reflecting on the Solution Explorer. In other words, the file exists, but it's not being recognized as part of the project. So there are a few ways in which we can correct this, but the simplest, we have to show all files. That's the first thing that we have to do. After showing all files, you can see that this file was hidden from us. It's because it's not considered to be part of the project. If you right click it, there's an option which says include in project. It's a different case for form 1 because it's already part of the project. You can only exclude it. So because DB was not included in the project when we created it, we were unable to use. Oh, now it's showing us a lot of errors which we can fix, fortunately. Okay. At least it's showing us a couple of errors. It's okay. So we can do this. So let's leave this part out. Okay, then this one is a void function. So there were errors in our source file, but they were not being reported because the file was not recognized. So let's try again to reference our database from this point. Oh, now it works. But the good thing is we don't need to connect or anything. We can start by reading. What happens here is when we call the query function, it first establishes a connection, then it configures the command and executes it, then returns the result. So I think then this should work for us again. This time, let's just get the address, I think. Let's see if this works. Okay, it worked this time. Okay, so let's try to deliberately cause some errors by just typing some invalid commands in here. Let's see how the database engine handles this. Oh, okay. As you can see, our database engine is now generating what we call an exception. So exceptions are errors that are unhandled. In fact, every error is an exception, but they must be handled properly. If they are not handled properly, they'll result in vague messages being passed to the user, like what we see on the screen, or they can result in a program terminating unexpectedly. We need to gracefully handle problems that might arise as we are trying to read from the database. The best way to do it is to use the try catch block. So if we say try, what we mean is errors could arise from these operations. Either the connection can fail, or something might go wrong with the command because a person typed an invalid query, or an error might occur while we are trying to read from the database. Either ways, all these instructions are likely going to cause an error. So we put a try block around all these potential errors. Then we have what we call a catch block, which starts just after the try block. So the catch block is used to handle errors, if any exist. So if we find ourselves here, it means an error occurred. So here, this is the place where we can display a message. And here maybe we can return a null value. So if we find ourselves here, it means everything went well. Okay. But also notice that this statement, the connect statement, takes us to this function here. So it also means if an error happens here within this function, it will be reported here. It's not a very good approach, because the error message that is showing can be misleading. Like in this instance, while we are trying to send a query to the database engine, that's where we encounter an error. So we say an error occurred while reading from the database. It doesn't accommodate the part where we try to connect to the database. So in any case, if the connection is the one that fails, we should have error handling within the connection part, so that even the error message that is delivered to the user is clear and it is not very confusing. So we should also put a try block here. So at least this one is handled properly here. And also because we have the, I think this can go outside of the try block, because this condition, it determines if we are going to try to connect in the first place. So this should make more sense. Okay. So there is a possibility that the connection could be now if a connection resulted in an error. So actually want to say if the connection is still now after this, then return the null value as well. So on this part, we must also say if reader we have to okay, let's see what happens this time. An error occurred while reading from the database. So if we wanted a preview of the error message, we could okay, we wanted it to continue executing with the modifications, but unfortunately, the application wanted to restart in order to apply the modifications. So now there's an error message that is showing, and it's also giving us the reason, which is coming from the database engine. This is not a very safe way of reporting errors in serious applications, because if you give an error message, like in this instance, the error message is specifying some parts of the query that we sent to the database engine. The danger of doing this is if there is a malicious person and they manage to understand how your application is communicating with the database, it becomes very easy for them to attack either the application or the database, just because you've given them more information about the structure of the database of the application. So it's highly recommended to hide errors, especially those that are very specific about how data is being passed between the database engine and your application. Okay. So I think for now, we are okay. So here we had said select from users. And this time we want to, or maybe let's run it again. Let's see what happens. Okay, so it prints the address, but because there's just one user, it prints just one item. So we want to add another item to the database. This is number 2. Okay, we've managed to create another entry. So let's run the So if we say login, I expect it to show 2 addresses the first one for the first user, the other one for the next user. So that's okay. So now let's move to the next step of our development. You must have noticed that when we click the login button, it is not validating the information that is in the username text box and the password text box. So it just proceeds. But what we want is a situation whereby we check if the values that have been supplied to us are valid or not. So we don't expect the username to be blank, and we don't allow spaces on the username. So what we're going to do is we'll put a string for the username and we'll extract the username txt with text. So this is our username and this is our password. Okay, so we now have our username in the variable u and our password in the variable p. So the next thing that we want to do is we want to test to see if the username is blank, or maybe let's remove the spaces before and after. So the trim function removes spaces at the beginning and at the end of the string. Let's say I entered my name Tinashe, but I put a space here and I put another space here. If I run the trim function, it eliminates the spaces. So this helps to ensure that a user doesn't put just spaces as the username. Okay, so the password, we don't need to bother ourselves trimming it just in case a person wants a password of spaces, although that's not a good password choice. So if the username has a length of 0, or maybe let's just say if the length is less than 4 characters, then we want to show an error message. Okay, then we return so that this function doesn't proceed. It shouldn't even attempt to log in a user with an invalid username. If the password length is less than how many characters? 6 characters. Then again we return. I don't know why it is suggesting this. So if we find ourselves here, it means username and password are okay, but it doesn't mean they are valid. Okay. Then when we are running our query, we have 2 options. Either we go through the entire list of users and we check each user by their username. So we check if each of the usernames match the username that was entered. So here is how we would do it. Knowing that the username is the string at index 1, Yes, thank you. So we could say if username is equal to you and password is equal to e, then then the break statement is used to terminate the while loop, because we can have a situation whereby multiple users are authenticated and it continues to show the user authenticated message. So after the first user has been authenticated, we just break from this. Okay, so let's see what happens. Administrator, and the password is password user authenticated. Let me try to mess it up a bit. Where did this happen? Okay, let me try to debug this error. Maybe let's start from somewhere around here. So okay, so this one runs the first time, but if we mess around with the password, okay, I understand what's going on. When we got this reader object, we didn't close it, so we can do that here. Okay. This time it works. Then now it worked because we closed the reader. After you have utilized the reader, you must close it. The reason being, the resources that are being used to remember the results from the last query, they are kept in memory unless you release them by calling the reader.close. So this time it will, nothing happens just because there is an invalid, nothing is happening. And if we restore it, the user is authenticated. Let me try the other user. What was his password? Let's try this. I need to visit him again. Username capital T. Okay. Okay. So our login functionality is almost working, but there are a few problems. We don't necessarily have to match the username after the database engineers returned the reader object. We can do it within the SQL query. The reason is databases normally compare things faster than our traditional applications. So it's advisable to allow the database engine to search for a user which matches the username that we've been provided with. So we can use the where statement, select all from users where username is equal to. So I'll put quotation marks here. And to simplify, because I want to also include the variable with the username. So either I can close these quotation marks and put plus signs and put AU, something like this, which is very difficult to read or understand, or I could just use the dollar currency symbol. Then if I put braces, it allows me to put a variable. So this is much easier and much readable than having to close and open too many strings. Okay. So this searches for all users who have a username which matches the username that was entered. So we don't need to test the username, we just need to test the password. Or maybe let's just keep the username there. Okay, so this simplifies our work. Username must be 5 characters. It's okay. Password must be at least 6 characters. Okay, still the user gets authenticated. But if we are going to check the username that is retained, let's say we say login, the username is Tinashe, so it's no longer returning the username for administrator because that one is filtered out because of this condition. All right. Remember what we said earlier. We said it is not advisable for the login form, which is part of the user interface, to be handling database matters, because these two, they exist for different purposes within the application. The purpose of a database is to facilitate for the storage and retrieval of information, and it uses technologies to do it in a fast and efficient manner. So the purpose of a user interface, on the other hand, is to communicate with the user and to pass messages to underlying functional routines so that they handle whatever commands might be coming from the user. So all these elements, they perform different tasks. So it's not a good programming habit for a user interface to be meddling with the affairs of a database, for example. So there's another mistake that we made, but it's not very obvious when you look at our program. So what we did, within our login form, we managed to communicate with the database, but that part is okay. But there is a part where we were too specific with the structure of the users table within the database. This shouldn't be the role of the user interface. So we should have created a class that handles users. So that class should be able to handle data transfer between the user's class and the database. So if the login form wanted to authenticate a user, it should have consulted the user class. Then the user class authenticates the user with the given credentials. So this should have been transparent to the login form. The reason being the login form is part of the user interface. It shouldn't be involved with the specifics of how information is stored in the database. So that's another mistake that we made. Let's say, for example, later we choose to change the structure of our database, so we choose to change the names or the columns, or we choose to change something within our database. That should not break the login form because it belongs to the user interface. We should be able to replace some elements of the program without breaking the functionality. Like, for example, what we did with the database so far, we should be able to replace the Microsoft SQL database with a MySQL database, or we can replace the database with an SQLite database. So that should be transparent to the rest of the system, and nothing else should break, and we should be able to replace components like the database with another without affecting other parts. But so far, the way we wrote our login form, it is now involved with how user information is stored in a database, which is a bit of an overreach. So in order to rectify that, we're going to create a user class. Okay, this time we are going to create the user class from the project menu, because the last time we used the file menu, then we created a class, but that class was not recognized in our project. But if we go on project, then we say add class. We want to create a user class. So the user class is maybe the first thing within a user class is the ID. Then we also have a username. So we'll try to use a 64-bit integer for privileges. We'll discuss later how the privileges will be used and enforced within the program, but so far then we need a public, and it's a static function which is called login. So by default we return false. So this function should accept a username and a password. So again, we are going to remove this information from the login form. So the login form must just have something like this. So we have a username and a password. So again, we show a message. So let's put this stuff here. So let's have a value in the for the return value. So just give it a value of false. Then the only time it becomes true is when we have confirmed the username and the password. So the reason why we use this variable is we have a reader object that we got from the database, and we need to close it before we exit the function. So while the loop is running, we can't close it. Well, we could have put another reader.close after confirmation of the user, but that would unnecessarily replicate the code. The danger of that is, let's say we had too many places that exit from the function. We might forget to put the reader.close on one of the exit avenues. As a result, we have errors emerging from places that will be very difficult to locate. So it's normally advisable to have one path which your program follows. So I would advise that we minimize the exit paths from different functions. That way, it's easy to locate errors if they occur within a program. Okay, so let's proceed. The user class is allowed to access the user database, but the login class is not allowed to know how the user records are stored, because the login form is part of the user interface. So it must simply mind the user interface business. How it does that is it keeps its job description simple. Whenever a user is to be logged in, it calls the class that handles that part of the program, and it remains within its scope of responsibilities. So let's see if this will work for us. Later we'll need another function which creates a user. Okay, it means the user is authenticated. We want an error message to show up when the user is not authenticated. So let's go back here. Oh, sorry. I think I've been doing it wrong. I forgot to drag the window to the visible area. Okay, so this time the user is authenticating, but if we put a wrong password, it shows an error message now. We can decorate our error message so that it portrays the appropriate message and it looks obvious that it's an error message. How we can do that is by exploiting the extra parameters. Here we just need okay, the icon. What else do we need? I think we are okay like this. So if there's an error, that's how we do it. But if there's no error, we want it to have an icon and a nice title. That's the caption. Oh, sorry, I forgot to drag it again. User authenticated, but if they are not authenticated, even the sounds, they are reflecting the outcome of the authentication process. So this looks better than what we had at the beginning. When the user is authenticated, we may want to move to the next form. Since it's a point of sale system, the next form must allow the user to operate the point of sale. So we have to create another form. So for now, we just create a form. This is the main form. So that from the login form, the new keyword is used to create a new main form. So it instantiates the main form object. And when it is loaded, it is shown as a dialog box. So this function will not return will not return until main form is closed. Okay, so we have commented out the part that shows the confirmation message, and we replaced it with the activation of a main form. So let's see what happens now. So I put a wrong password, shows an error. If the password is correct, it takes us to the next form. But if you can notice, the login form is still visible. So we need to deal with this. The best way to do it is to first say this dot hide. This pertains to the current form, which is the login form. So we hide it first, then we show the main form. Okay. And one other thing that we need to do when these forms are loading, we want them to load on the center. So the default position should be on the center of the screen. So that's the main form and the login form. The default location is the center. Okay, then we have that issue that we pointed out at the beginning, where I said focus is on the password, then it goes to the username, then the create. It's unpredictable how focus will be passed from one element to another. So the way I normally fix this, I don't know if there's a better way of doing it. But how I normally do it, I go to the form, like in this instance, it's form 1. Then I've opened the designer. Then I expose the source code. So normally I don't worry about the labels, but let's say I want the username to be recognized first. I put it at the beginning, followed by the password, then the login button, then lastly the create button. Let's see how this will turn out. Okay, this works for me. Then login, then create. Excellent. This is how I solve this problem. I don't know if there's a simpler way of doing it. Okay. So we now want to design the main form for our point of sale system. And this is the part which will display products and where the user can enter any sales that the business might be having for that particular day, and eventually we must be able to produce a receipt. Later we'll add product management and user management facilities within the system.